Okay, hello. Here we are for 1.5 angle pair relationships. All of the angles that it's talking about in this chart here for the examples are referring to this picture, so keep that in mind. I'm going to go ahead and wait for you to pause this, copy all this down if that's what you want, but you probably won't have enough time to copy all this down while we're talking. So take a minute to do that and then come back here. Okay, so we're going to start actually at the bottom of the chart because these are pretty straightforward. So complementary angles is just a pair of angles whose sum is 90 degrees. So they don't have to be next to each other, they don't have to be on the same plane. If you have two angles who, when you add them up, it equals 90 degrees, that's called complementary. 70 plus 20 equals 90, so these two angles are complementary. Supplementary is two angles whose sum is equal to 180 degrees. We'll use this one a bit more frequently throughout the year. So as you can see, 135 and 45, if you add those up, it equals 180. So therefore, these two angles are supplementary. Again, they don't have to be next to each other. They don't even have to be on the same plane. If I have a 100-degree angle in one part of the classroom and an 80-degree angle at your house, those two angles are 180 degrees, so they're supplementary. So these top three terms here are a little bit more involved, so let's take a little bit more time to talk about them. And these two in particular, linear pair and vertical angles, are very important, and we use them a lot throughout the year. So make sure you have a good understanding of that. And remember, all of the Chapter 1 vocab is on my website, so if you want to look that over and practice and make sure you have a good understanding of the vocabulary, that will help you going forward with this chapter and the rest of the semester. So first we have here is adjacent angles. Adjacent means next to, and that doesn't just mean in geometry, okay? Adjacent means next to in other situations too. In chess, the queen and king start out adjacent to each other on the board. In football, the center is adjacent to the two guards on the offensive line. Adjacent is next to. So if you look at angle 1 and 2, I have a big angle here. This big angle is composed of angle 1 and 2. Now, when I trace angle 1 and I trace angle 2, I notice two things. One of them is that they share this ray, so they share one side. And the other is that the vertex of the angle, the point where the two rays are coming off of, is right here for both angle 1 and angle 2. So we can say that angle 1 and angle 2 share a vertex, and they share one side. And they don't overlap. So that's called adjacent angles. 1 and 2 share a side, share a vertex. They're next to each other, adjacent angles. Okay? Now, there's a specific type of adjacent angle which we use a lot in geometry called a linear pair. If you look right at the word, it will tell you what it means. It's a pair of angles that forms a line. It's right there in the word. So, here's angle 7 and angle 8. First of all, let's notice that they are adjacent. Trace angle 7, trace angle 8, and you'll see that they share this side, and they both have this vertex right here. So they're next to each other. They're adjacent. But you can tell that they're a linear pair when you look at the side that they don't share. Here's the side that 7 and 8 share. Watch what happens when I trace the sides of angles 7 and 8 that are not shared. You'll see that it's right here. It's this line. So we have two adjacent angles, two angles that are next to each other, and their non-shared side is forming a line, so they're called a linear pair. Now, a straight line is always equal to 180 degrees. So since angle 7 and 8 are forming a 180 degree line, that automatically means that if we add up their measures, it will equal 180 degrees. So linear pairs are always supplementary. If you add them up, they always add up to 180 degrees. Our last term here is called vertical angles. We get vertical angles by drawing in two intersecting lines. So look at my two lines. What you should notice, and if you just go ahead and take your hand and cover up angle 1 and 4, and you'll just see 2 and 3. You should notice that those are a linear pair. They're next to each other and they're forming a line. If you cover up angle 1 and 2, you should notice that 3 and 4 are a linear pair. They're forming a line. Same thing with 1 and 4 and 2 and 1. So the two intersecting lines makes 4 linear pairs. 2 and 3, 3 and 4, 1 and 4, and 2 and 1. Those are all going to be supplementary. But what you also should notice is out of these 4 angles, you get 2 pairs of angles that are not adjacent. So look at 2 and 4. Okay? Those 2 angles share this vertex here, the intersection point in the middle, but the 2 angles are like shooting off in exactly opposite directions. They don't share a side. They just share that vertex. In this situation, 2 and 4, those angles are called vertical angles. And it's the same thing with 1 and 3. They're sharing a vertex, but they're shooting off in opposite directions. They're not sharing a side. They're vertical angles. Vertical angles are always congruent, and a linear pair is always supplementary because it forms a straight line. Those are the 2 things you want to use, and those are going to drive the equations that we use. Just like we've been doing in Chapter 1, part plus part equals whole, or setting congruent things equal. So if you look at the diagram for example 1, they gave us this measure is 36 degrees and they want the other 3 angles. Well, it's 2 intersecting lines. So I should know that this 36 degree angle and this angle 2 are vertical angles, so they have to be congruent. So if this is 36 degrees, this is 36 degrees. That's where I got that. Okay? Now, cover up the 36 degree angle and the angle 3 with your hand or with a sheet of paper, and now just look at 1 and 2. And you should be able to see they're right next to each other, and they're forming this line, so they're a linear pair. So they have to be supplementary. They have to add up to equal 180 degrees. So since angle 2 is 36 degrees, I would just do 180 minus 36, get 144 degrees for angle 1. And angle 1 and angle 3 are vertical angles, so they have to be congruent. So if angle 1 is 144, angle 3 is 144. Okay? Also, like we said, these 2 angles here are supplementary because they're a linear pair, so they, as you can see, they add up to equal 180. These 2 angles are supplementary, they add up to equal 180, etc. Okay? We're going to do the same thing for example 2. Find which one they gave me, which was this one, 157. These 2 angles here, the 157 degree, angle MOA and angle HOT are vertical angles, so they're congruent. Their measure is equal. If this is 157, this is 157. And then these 2 angles here, MOA and AOT, those are a linear pair, so they have to be supplementary. They have to add up to equal 180. So I just do 180 minus 157 to get the 23. Okay? Now, for these ones here, again, if you want to pause and copy everything down, that's fine. I'm just going to talk through them step by step. I'm not going to write them all with you. So it says here, angle A and angle B are complementary. That means if you add them up, it equals 90. So I'm going to take the measure of angle A and the measure of angle B, and they're going to equal 90. So it's just a linear equation here. You're going to combine like terms and solve for x. Now, what people miss on the quizzes and tests for these is they're used to just, again, still just solving for x and thinking that the problem is done. But the problem doesn't just say what is x. It says find the measure of angle A and the measure of angle B. So once you solve for x here and you have 19, you have to plug this in to angle A and you have to plug this into angle B to get these 2 angle measures. And you can check to see if you're right by saying, look, if I add these 2 up, do they equal 90? 22 plus 68 is 90 degrees, so they are complementary. And we're going to do the exact same thing over here for C and D, for example 4. C and D are supplementary though, so instead of adding our angles and setting it equal to 90, we're going to do part plus part equals whole, and what is it? Supplementary is 180. So we solve for y, and then we're going to plug that back in to get the measures of angles C and D. So example 5 and 6 get a little bit trickier. First thing we want to do is try to solve for x. What you're supposed to notice here is the angle UZV, this angle here that's defined as 4x minus 7, and angle VZW, the x plus 22, those two angles are next to each other, and they're forming this right angle here. That's what the marking means. So that means that this angle plus this angle are complementary. They equal 90. So I set them equal to 90 degrees, and I solve for x. And once I do that, I'm going to substitute that into this expression and this expression, and I get that this angle is 53 and this angle is 37. And if you double check, 53 plus 37, that does equal 90. Okay, so that's this one, UZV, and WZV, or VZW. Now, they want to know these other angle measures here, like X, Z, Y. So this problem becomes a little easier if you can just ignore ZW right now. So just kind of cover that up with again with a sheet of paper with your finger, and just look at VZU and XZY, these two angles here. Do you see that they're vertical? They're formed by two intersecting lines, and they're across from each other, so they're going to be equal. So if this one's 53, then XZY is 53. Okay, and then they want to know UZY. We'll trace UZY. See that? You see how that is vertical to VZX? Again, if you ignore ZW, you can see that VZX is vertical to UZY. So UZY is going to equal whatever VZX is. Well, VZX is made up of this 37-degree angle and this 90-degree angle, because remember, UZX here is a straight line. That has to equal 180. So if this is a right angle 90 degrees, so is this. So VZX is 37 plus 90, that's 127, and UZY is 127. In example 6, we're going to do something similar. But what we're trying to do is we need two different equations. We don't want an equation that has both an x and a y in it, because then we can't solve it. So even though AEB and CED, these two are vertical angles, I'm not going to set them equal necessarily, because there's an x and a y, although you actually can do that if you want to do a system. But if you look at AED, that's a straight line. So if BED is 80 degrees, AEB has to equal 100 degrees, because they are a linear pair. They're supplementary. So I set 3x plus 5 equal to 100. I would have got the same result if I did 3x plus 5 plus 80 equals 180. I solve, I get x. Here's x. Now, for y, I say, okay, look, if this top angle here, AEB, is 100, isn't CED also equal to 100? Because they're vertical angles. So I set 3y minus 5 equal to 100 to solve for y. Once I get x and y, I just substitute them in to the different expressions to get the value. So I put 35 in for CED, and I get, well, I would get 100, but like we said, we already knew that one's 100. And if I want to get AEC, I could either just plug in the 35 to here. 2 times 35 is 70, plus 10 is 80. Or again, I could recognize that AEC and DEC are adjacent and forming this line. So they're a linear pair. They're next to each other. They're forming a line. These have to add up to 180. So this is 80. You also could notice that AEC is vertical to BED. So these have to be congruent. So there's a lot of ways to arrive at the answer. What you want to remember with this is the linear pair is always supplementary. Two adjacent angles adding up to form a line. And vertical angles are always congruent. And then we have one more term for you here at the end, which we'll use a lot going forward, which is perpendicular lines. So when you have two lines that intersect at a right angle, that's called perpendicular. The symbol is this, an upside down T. And just remember that all four of these angles are going to be right angles, because 2 and 3 are vertical. They have to be equal, right? 90, 90. And 2 and 4 are a linear pair, so they have to add up to 180. So if this is 90, and these two have to add up to 180, 90 plus 90 equals 180. So you would get 90, 90, 90, 90. Perpendicular lines are two intersecting lines that form all right angles. That's 1.5. Again, make sure you learn those terms and check out the website for more help with vocabulary if you need it. Thanks.